Okay, after yesterday's or the last lesson, I thought we could now move on to looking at pointers and arrays. Now, something very special in C++. Let me get rid of all this again. Start a new program. In that, everything's pointers really. It's very weird. It's not like other languages at all. So it's actually quite hard to send an array to an outside function. You have to do clever things like wrapping things in structs, which is way beyond where we need to be at the moment. But let's play with arrays and pointers then. First of all, let's set up a simple integer array. We'll give it 3 elements. Nice and simple. We'll use hard coding in this program because we need to get to the point of pointers and arrays rather than worrying about that. Okay, now here's something a bit odd. Have a look at this. Hopefully this will work. Let's run it. Look at that. A int, which is just being declared as the name of an array. It's just an array. Now I don't need to put a number in there because I'm immediately declaring there's 3 things in it. So the compiler says, it's an A int 3. So we're all happy there. What does that look like? Doesn't that look like a pointer? Looks like a lot like a pointer to me. Let's even do this. Star p int. Now we're going to have a couple of pointers in this, so I'll call this p int 1 equals a int. And let's print out what point 1 looks like. Let's point it to a function. So line those up, make things a bit more obvious. Look at that. Identical. The pointer and the array name are both identical. In many ways, and it's probably beyond the scope of this video to go into it, the name of an array is a pointer. It might make a little bit more sense if I create another pointer. Let's just copy this code to protect the innocent. So if I have a second pointer, and we'll do the traditional thing with pointer. We'll have an address, and we'll say we're going to point at the first element of the array. Now let's see what that looks like. Probably look like something different. Hopefully it'll look the same. Yes, you can see they're all the same. They're the same thing. So the name of the array here is really a pointer in disguise. The pointer that we've created from the name of the array is a pointer, but it's not in disguise, it is a pointer. Oh, by the way, there's nothing special about p making something a pointer. I can quite easily call a pointer int1 like that. No problem there. It's just that by convention, they're just variables. By convention, we do put a p on the front just so that we know what we're doing. You can have arrays of pointers. You can treat them just like you can treat any other variable. It's just the p doesn't make it a pointer. The thing that makes it a pointer is this. And then the third pointer, so we've got a int as a pointer, we've got point1 as a pointer. Point2 is how we'd normally set up a pointer for a single variable that isn't an array. The address on the front to the first element of the array. So it's the key. There's a street with 3 houses in it, and this is saying, give me a copy of the key to where the first house is. From there, I can then move into houses 2 and 3. Okay, now how then do we pass? Let's pass this information off to a subroutine and then get the subroutine to print out these contents. Now, again, beyond the scope of this lesson, you can actually pass an array by value if you wrap it inside you do a horrible thing with a struct. But C++ says, no, this is a programming language for grown-ups. If you pass an array to a subroutine, we're going to just pass the address. And if you mess up the array inside the subroutine, well, then you mess up the array, and that's your problem. This is a language for grown-ups. So let's, seeing as these are all pointers, this one really being a pointer in disguise, let's send these off to a function called fPointer. Send off the name of the array. At the moment, obviously, I haven't declared that function, so let's write that function. And this function is it's going to be a void function. It's not going to return anything. It's going to return nothing, and it's going to take in a pointer at the start. And so we say int star p input. We'll also, I think, I could hard code this to a 3, but let's do what we'd normally do. Send in the size of the array as well as an int. There we go. So, give me a pointer. No, I've sent in an array name. Oh, I need to put the size of the array in, don't I? So it's 3. Should make it happy. Sending in the array name. This program, this subroutine's clever. It goes, no, I'm quite happy with this being a pointer. By the way, why do we say int? Why don't we just say pointer? The reason why is the pointer needs to know how big the blocks of memory are inside the array. So if an int takes 2 bytes, the pointer needs to know that every time it moves one along, it moves 2 bytes along. So it's a bit like a typewriter. You need to tell it how many lines you want it to go down when you press the kind of carriage return key. Do I move down 1 line for single line spacing? Do I move down 2 lines for double line spacing? If there was such a thing as an 8-line spacing command on a typewriter, if you press the carriage return, it moves down 8 lines. So the reason we do that, the reason we tell it what kind of a thing we're pointing at, is so that it knows how many bytes to move along, because in a few minutes we're going to be adding on stuff to that, and every time we do that, it moves the address along by however many bytes this thing is in size. So it's going to move along 4 bytes or 8 bytes or 2 bytes or 16 bytes, depending on how this is sized on your particular computer. Anyhow, let's move on. Let's print out the contents of this array pointed to by this pointer. Okay, the usual for loop. I is less than size of array, which is this chap here. And as long as it is that, we're going to add one on to pointer to the I. Sorry. Okay, so let's print out the. We'll do 2 things here. I think what we'll do is we'll print out what p input is. What actually its value is, and then also as well we'll print out what the value that it's pointing at as well. So from last time, what's that thing pointing at? Oh. Now you know I like to line things up, so there we go. So let's see. Oh, yes, forgot to do something. We're not going to move along using I++. That's just a kind of marking thing. That's just like the baton of a conductor. I'm going to move along. Actually, let's not move along. Let's just see what happens when I don't do that special thing I was about to do. we start at 101, the next one's 101, next one's 101. We're not using I++ at all. First one, second one, third one. So how do we move along the array? Well, we need to do that special thing that I should have done a minute ago. We need to go p input ++. Now, it isn't really an ordinary variable, a pointer. It's not totally ordinary variable. C++ knows that when we do addition mathematics with a pointer, it goes, what kind of a pointer is it? It's an int pointer. I know how big an int is on my machine, 4 bytes or whatever it is. So I'll add 4 bytes onto its memory position. So this memory position here should move along by 4 bytes or 8 bytes or 16 bytes. And it will then look inside and see what's inside the next thing. So now, if we run the program, you can see this time the first memory address is fine, the same, but then we've added 4 bytes on. It's hard to read hexadecimal notation, but you can probably see that between there and there. So 50, and then we do a ++, and then it's 54 at the end there. So 4C in hexadecimal, 4 bytes along goes to 50, then 4 bytes along goes to 54. That's all done by the ++ and by the int there, telling it how many bytes to move along. Now you'll notice, those of you who are ahead of me will notice that hasn't that gone beyond the end of the array? I mean, we've gone 0 to, we're at 3 now, aren't we? So surely that's going to go beyond the end of the array. Well, it will. Let's have a look. That was a deliberate mistake. Let's have a look and see what we've got. So after the for loop, what have we got now? And you can see that, actually, just so we can see what we're doing. We have moved along 4 bytes, notice, 54, 58. But we've gone beyond the end of the array, so we've got some spurious information inside that next group of bytes. Who knows what that is? It could be a float, it could be two floats, it could be, or a float, it could be a double, it could be part of a double. I've no idea what that is, and you do not want to mess with it. You could break your program very easily. You might get away with messing around with it, you probably won't. We have gone. The pointer is now pointing beyond the end of the array. The array only has 3 elements. First element starts there, second element starts there, the third element starts there. The program has no idea what that's the start of. Could be anything. And it's often very dangerous. You can see something. Who knows what it is? Okay, so I don't like messing around like that, so I'm actually going to get rid of... Oh no, I'll leave it in for you to have a look at later. But, just stay away. Just say no. Just say no. Now, one other thing I'd like to do then, if these pointers are all the same, then if I change to that or that, I should get exactly the same results. So let's try it. These are all equivalent, sort of logically. Does it produce the same results? Crossed fingers. Yes, it does. They're all the same. They're all pointing towards the same thing. Same addresses. Same values. If we go beyond the end, we get the same thing beyond the end. Now, just to finish off this lesson, you might see a slightly different notation with arrays to this, but it's very, very similar. let me write out how you might also see this. So if I do a different function, send in the array, so we haven't declared that yet. We'll copy this line, we'll copy most of this. It'll be very similar. But we're going to change particularly that first line. So we're going to call it f full array. And here, I'm going to change that to int input array. Now be very careful here because this is still really a pointer in disguise. So I can show you that via the following bit of code. So let's just put out what input array looks like. Let's have a look at that. I'll have to fix all of this. Let me just actually I'm going to do something I hate doing normally, but should solve a problem for a second. Right, let's print that out. Does that look familiar? Input array. Yeah, it looks familiar, doesn't it? Look, it's that. It's the same thing as that. It's not a different array. We haven't passed by value. It's the same array. Same array. And if we change the values of this array, we're going to change the values of the calling array. So let me just try and show you that too while we're here. If I change the first element of this input array and I double it, remember the first element of the array was, what was it? Oh yeah, 101. And then after I've called this function, I print out the first element of this main array. Again, flying by the seat of my pants again. Notice how it's now gone to 202. The first element of the array has now doubled in size. Now, if that looks like a bit like the second element there, let's use a slightly different operation. Let's just add 2, and this should go to 103. 103. So if you send off an array to a function, and then and even though it's a different name, don't care, you change that array inside the function that looks like a local array, you will change the main array here that you sent into the subroutine. So do be aware of that. There is a way round. We might get around to it in lesson 592 to do with structs, but just be aware of that notation. Now what we'll do is we'll just finish this program off. Let's leave that there just so that we see it in the finished code. Let's uncomment this code here. We just need to change this stuff, don't we? So input array. Actually, this is a bit of a mess. Let's start again with this before I lose the will to live. Okay, so we're going to say tell me what the ith element. We are going to use I this time. What the ith element is of That doesn't mean anything in this subroutine. So let's p input, so we don't need to do that. We are actually using I++ here, and we're looking at the ith element, the 0th element, then the first element, and the second element. Let's give it a whiz. So 103, 202, 303, and we've changed the first element. And here's another interesting thing. Well, I think it's interesting. You might not think it's interesting. Let's just print out these addresses as well. The address of this thing. Give it a whiz. And just note, if I can get them all on one slide, just notice that the input array address for the 0th element is there. The input array address for the second element is there. And the input address for the array for the third element is there. Yes, these addresses have changed from one of the other runs. These addresses can change every single time you run a program, but the relationships will be very similar, if not identical. So it's all 4 bytes on, and so on. So there we go. I think we're done. Hopefully that's made a bit of sense. Little recap. When you pass an array to a function in C++, you're really passing a pointer in disguise, and that's to speed things up massively. You're pointing at the same piece of memory, and even though you've given it a different name, or you're using a pointer, if you mess around with that array inside the subroutine, you're messing around with the array inside the main program. Anyway, I think that's enough for the moment. See you next time.